So in this video here, we're going to look at the points, the turning points in further detail, and we're going to also look at the inflection points as well. So we've got some basic points, some basic features sketched out onto our graph, and these guys were all, not all, I'll tell you what they were. These two here, -3, 0 and -1, 4 were turning points. This one here is just an intercept that goes through the graph. 0, 0. So that didn't come through as being a point of either an inflection or any kind of turning point. It's just somewhere where the graph crosses that point. So it's coming through there somewhere. So this guy here, if it's a maximum turning point, the graph will be coming up, turning around, and this one is possibly a minimum, and then the graph goes this way. Alternatively, if this one was a minimum, then we may have maybe something we're missing. So that could be a minimum, that could be a maximum. It's unlikely, but what we want to do is formally test these points. So in our steps, we have there that we can use second or first derivative test to figure out what's going on with the stationary points. At this stage, your book requires you to use the second derivative, but I'm actually going to do the first derivative to check out those points together with you, because it is something you should be able to do, and I believe you probably have done it. So to do a first derivative test, we use the first derivative equation, and we're basically going to plug and place some points in either side of the relevant turning points. So for -3, 0, I'm going to choose x of -4, which is to the left of that point, and also x of -2. So I'm going to try and see what f dashed -4 looks like, and also what f dash -2 looks like. So this is the first derivative, so I'm going to plug and play those things in. So at the point -4, the derivative or the slope ends up being 9, which is positive. So that means that the graph is going up in that direction. We are now going to look at -2, so we're going to plug and play that into the first derivative equation. And that equation then pans out to be -3, which is negative. So that means that the gradient at -2 is down. So we know the gradient at x equals -3 is 0. And just to the left of it, we're climbing up, and then we're climbing down. So we can say, using the first derivative test, that this point here is a maximum. So the graph's coming up round this way like that. So let's kind of sketch that in. Now we also know that when it hits -1, 4, it's turning around in some way. We know just to the left of it, it's negative. There's nothing else going on there. We could go -1.5, but we're going to use the information to the left as what we used for the right side of the -3 point. So we're going to do that. I'm just going to write out here -1. We know that at -1 it's flat. To the left of it, it's coming down, and we're just going to test a point to the right of it. So I'm going to very conveniently pick f dash of when x is the 0 point there, and I'm going to examine its behavior using the first derivative. So I'm going to plug and play 0 into the first derivative equation now. And checking this out, plugging that in gives us a value of 9. So the gradient is 9, which means that we're coming up this way when it's 0. So if we come back here and look at our graph, we can visualize that as we're coming down here, it's negative, it's 0 here, so it's turning, and it's positive on the other side. So I'm just going to put some sketch notes back in here. So we know that it's going up there, and we know it's going through that point. So we've pretty much sketched it. So we have done a first derivative test to identify the nature of the turning points. We haven't specifically done the second derivative test or looked at inflection points yet, but we've just gone over this first derivative, and it's for your interest. The next video will show how we bypass this step and just use the second derivative for the turning points and also for any further points of inflection that the second derivative helps us to identify.